Good morning to all. Okay, in the previous lecture, we've seen that two examples, and this one is the third example for your homework. Okay, have you solved it? Hello, am I audible?
Yes, sir.
सॉल्व केलं का एक्झाम्पल? नसेल तर सांगा म्हणजे सॉल्व करूया. ओके, प्रयत्न तरी केलात की नाही? नाही. शांत आहे की नाही? ओके, लुक ॲट द एक्झाम्पल. इफ p इज द प्राइम
Yes,
नंबर,
sir.
देन काही जण केले असतील पण बाकीच्यांचं नाही केले असतील. ओके, ठीक आहे. If P is the prime number, then prove that the splitting field of F over F, the field of rational number. Okay, what is F is given? F is equal to field of rational number. Then the polynomial x raised to P, okay, and minus 1. Okay, of degree. What is the polynomial degree? Degree of polynomial is P, prime number. Okay, x raised to P minus 1 is of degree P minus 1. Okay, if suppose E is the splitting field of this polynomial over the field of rational number, then degree of E over Q is P minus 1. Okay, look at here. Here, the degree of the polynomial is prime, but degree of the extension field, that is splitting field, over the base field, rational number, is P minus 1. Okay, we have to prove this one. Now, look at the proof, solution. The polynomial, आवाज येते ऐकू व्यवस्थित?
Yes, sir.
f of x is equal to x raised to p minus 1, which is belongs to capital F of x, that is equal to field of rational number. Okay, ring of polynomial over the field of rational number. Now, f of x, we can write is f of x is in the form of product of two polynomials. Which one? X minus 1 and another factor is
X raised to P minus 1
Plus x raised to
plus X raised to P minus 2
up to so
up to
on
so on plus 1.
x square, x square plus x plus 1. Okay, for example, suppose x cube minus 1. What is the formula of this one? X minus 1 and x square plus x plus 1. Okay, what is the formula of this one? X minus 1,
X minus 1
x
X raised to 4
4
plus X cube plus X
cube.
square plus X plus 1.
Okay, this one. Okay, so here f of x we can write in the form of product of two polynomials such that f of x is equal to x minus 1 into x raised to p minus 1 plus x raised to p minus 2 up to so on x square plus x plus 1. Okay, now let this g of x is equal to x raised to p minus 1 plus x raised to p minus 2 plus up to so on x square plus x plus 1. Okay, what is the one root of this f of x? X is equal to 1 is one root of this polynomial f of x. Okay, now since, look at here, since 1 will be 1 belong to any extension of f, any extension of the field f. Okay, जर तो field असेल तर त्या field मध्ये हा always 1 असेलच तिथे. Okay, unit element. Okay, okay, we have to find the splitting field of f of x. That means the field such that we can write this f of x in the form of product of linear factor. Okay, हा तर linear factor आहे. Okay, x minus 1 आणि हा 1 always तुमचा f मध्ये आहे. ओके, मग काय करावं लागेल मला? या पॉलिनॉमियलचे सगळे मला रूट्स काढावे लागतील आणि ते रूट्स कोणाला ऍडजॉइंट करावे लागतील? फील्ड ऑफ रॅशनल नंबरला. ओके, सो 1 will belongs to any extension field f. It follows that the splitting field splitting field of q of x or g of x. The q of x q g of x में. If it follows that splitting field of q of x will be the splitting field of
F of X.
hmm. Okay, instead of here you have to find splitting field of f of x. Here we have to find the splitting field of q of x. Why? Because one is always belongs to any field, any extension field. Okay, so field of q of x will be the splitting field of f of x. Any doubt up here?
No,
No,
sir.
sir.
Okay, now the by using Eisenstein criteria irreducibility. Okay, semester 1, by using Eisenstein criteria of irreducibility. Okay, what is the criteria? If q of x is irreducible over f, this polynomial x raised to p minus 1 plus x raised to p minus 2 up to so on x square plus x plus 1. This polynomial is irreducible over the field f. ओके, माहिती आहे ना आयसोसेशन क्रायटेरिया? काय क्रायटेरिया तो? p divides a naught, p divides a1, p divides up to so on an minus 1, and p does not divides an, and
AN.
p square divides a naught. Okay, असतं आहे ना?
P square does
Yes,
not
sir.
divide P naught.
P square does not divides a naught. Then the polynomial q of x is irreducible over the field of rational number. Okay, here what f is what? Rational number, na? So rational number set a criteria. Okay, so here by the Eisenstein criteria of irreducibility, this q of x is irreducible over the field of rational number. Okay, and also we have the degree of q of x is what? P minus 1. We have the degree of q of x is equal to p minus 1. Okay, so for this polynomial, we have how many roots? P minus 1 roots. Okay, now the degree of q of x is equal to p minus 1. Suppose if alpha is a root of if alpha is the root of q of x in some extension of f, some extension of f, then what we have, this q of x is irreducible element and alpha is the root of q of x. Then we can say that this alpha is algebraic. Algebraic element over the field of rational number of degree. What is the degree of this
P
element?
minus 1.
P
P
minus.
minus.
Okay, now adjoint this root, which one? Alpha, to the field of rational number. So the degree of f of alpha over the field of rational number is equal to p minus 1. Okay, because alpha satisfies the root irreducible polynomial of degree p minus 1. Now f of alpha, capital F of alpha. Okay, sorry. This capital F of alpha is a minimal extension. Minimal extension of both f f of alpha is the minimal extension of f containing both the field capital F and the element alpha. Okay, so by the definition of splitting field, look at here. Therefore, no extension of F, no extension of capital F of degree less than p minus 1 can have a root alpha of u of x. Okay, is it correct this statement? Therefore, no extension of f of degree less than p minus 1 can have a root alpha of u of x. This one is f, and this one is f of alpha. Okay, alpha is the root of q of x in some extension of f. Okay, suppose here the alpha is there. Okay, and degree of f of alpha over f is what? p minus 1. ओके, हा तुमचा सगळ्यात मिनिमल, ह्याच्यापेक्षा छोटा कोणताच एक्सटेन्शन येणार नाही f चा. Okay, there does not exist any extension of f such that both contains f and alpha. Okay, so this implies if capital P is splitting field, capital P is splitting field of q of x, it implies the degree of E over f. Okay, degree of E over f एक तर काय असायला हवा, p minus 1 असायला हवा किंवा greater than p minus 1 असायला. Okay, any doubt? If
No,
E
sir.
is the splitting field of q of x, then degree of E over f must be greater than or equal to what? p minus 1. ओके, आता आपण काय पाहिलं, एकच रूट घेतलाय आपण आता. कोणता? अल्फा हा एकच रूट अज्युम केलाय. सो एकच रूट काय केलं, f ला ऍडजॉइंट केलं आणि त्याचीच डिग्री किती आली, p minus 1. ओके, अजून किती रूट्स आहेत, q minus 2, p minus 2 रूट्स आहेत अजून. ओके, ऍडजॉइंट करायचे कोणाला, f ला. Okay, so if E is the splitting field of q of x, then degree of E over f is always greater than or equal to p minus 1. Okay, एक तर p minus 1 असेल किंवा p minus 1 पेक्षा मोठा असेल, ह्याच्यापेक्षा छोटा असणार नाहीये तो. Now, claim. The degree of splitting field E over f is equal to p minus 1. We have to prove that degree of E over f is equal to p minus 1. Okay. Now look at here. Let us solve. X raised to p minus 1 is equal to 0 in the field of complex number. Okay, do you know about the nth root of unity? Forms a cyclic group with respect to multiplication modulo p. माहिती आहे
Yes,
का
sir.
हे? एखादा nth root of unity काढल्यानंतर त्याचे nth रूट काढलो आपण, समजा जे काही n रूट असतील तो काय फॉर्म करतोय, सायक्लिक ग्रुप फॉर्म करतोय. केला असेल बेसिसला 1 अल्फा, अल्फा स्क्वेअर, अल्फा क्यूब अप टू अल्फा n minus 1. Okay,
Yes, sir.
all the roots forms a cyclic group with respect to multiplication modulo n na.
Yes, sir.
Okay, now let us solve. X raised to p minus 1 is equal to 0 in C. Okay, म्हणजे काय करावं लागतील आपल्याला, मला हे सगळे रूट फाइंड आउट करण्यासाठी. Okay, so this implies x raised to p is equal to 1. This implies x is equal to 1 raised to 1 upon p. Okay, so this implies x is equal to 1 plus I0 raised to 1 upon P. Okay, this implies x is equal to what is 1? Cos 2 pi n, cos 0, cos 2 pi k or 2 pi n plus I sin 0, that is 2 pi k bracket as to 1 by p. This implies by de Moivre's theorem x is equal to cos 2 pi k divided by p plus I sin 2 pi k divided by p, where k running from 0 1 up to p minus 1. Okay. Okay, what is the value of this one? Look at here. So this implies x is equal to e raised to I theta. Okay, that is theta is what here? 2 pi k.
2k pi upon p.
Okay, where p running from k running from 0 1 up to so on p minus 1. Okay, now putting x is equal to k is equal to putting values of k from 0 to p minus 1, we get what we get? X is equal to put x k is equal to 0, e raised to 0 is 1. Put k is equal to 1, e raised to I 2 pi upon p. Okay, e raised to I, put k is equal to 2, 4 pi divided by p. Okay, up to so on, e raised to 2 pi p minus 1 divided by I divided by p. Is it correct?
Yes, sir.
Okay. Now we have hmm, alpha is equal to, or let alpha is equal to e raised to I 2 pi upon p. Then the values of x. X is equal to 1. This one is alpha. This one is alpha square. Okay, alpha cube up to so on. Alpha is to p minus 1. Okay, so as these p roots of x raised to p minus 1 is equal to 0 in complex number. Okay, set of complex number. So these p roots forms a cyclic multiplicative group. Okay, cyclic multiplicative group of prime order p. ओके, हे सगळे जे रूट्स आहेत किती एलिमेंट्स आहेत त्याच्यात? पी रूट्स, पी पी एलिमेंट्स विथ मल्टिप्लिकेशन दे फॉर्म्स ए ग्रुप. ओके, विथ प्राइम ऑर्डर. आता ह्याच्यात मल्टिप्लिकेशन मॉड्यूलो पी आहे की मल्टिप्लिकेशन आहे मला जरा नक्की माहिती नाही, ते तेवढं चेक करा. ओके, सो देन 1 alpha square up to so on alpha is to p minus 1. Okay. Is cyclic group. Okay, then look at here. The field, which one? Which field? F of alpha. Okay, या field मध्ये alpha आहे. Alpha belongs to f of alpha. म्हणजेच काय? त्याच्यात अल्फा स्क्वेअर आहे, अल्फा क्यूब आहे, अप टू सो ऑन अल्फा रेज टू पी मायनस 1 पण ह्या फील्ड मध्ये ऑलरेडी आहे. ओके, so the field f of alpha contain contains all the elements 1 alpha, alpha square up to so on alpha is to p minus 1. Thus, the field f of alpha splits x raised to p minus 1. Any doubt?
No, sir.
Since since alpha is root of x raised to p minus 1 and alpha is not equal to 1, this implies alpha is the root of x raised to p minus 1 plus x raised to p minus 2 plus up to so on x square plus x plus 1 is equal to 0. Okay, or it is not necessary. Here, the alpha is the root of q of x, which is irreducible, irreducible over f, that is set of rational number of degree p minus 1, and this implies alpha is algebraic element of degree p minus 1. Algebraic element of degree p minus 1 over the field f, that is field of rational number. So this implies degree of f of alpha over f is equal to p minus 1. Okay, any doubt?
No, sir.
इथे हे घेण्याचं कारण काय? अल्फा अल्फा स्क्वेअर हा डी मॉडेल यूज करण्याचा अर्थ काय की जे काही बाकीचे रूट्स आहेत पी मायनस 1 रूट्स आहेत, ओके, 1 ला सोडून इथे हा 1 रूट तर ऑलरेडी एक्झिस्ट आहे तुमच्या पी मध्ये, ओके, एफ मध्ये. मग ह्या पॉलिनॉमियलचे जे काही रूट्स असतील ते पण रूट्स या एफ ऑफ अल्फा मध्ये आहेत. इफ सपोज अल्फा इज द रूट ऑफ क्यू ऑफ एक्स, then there is no need to join again alpha square alpha cube. ओके, त्या फॉर्म मध्ये येतील अल्फा अल्फा स्क्वेअर अल्फा क्यूब. जे बाकीचे काही रूट्स असतील ते कशा फॉर्म मध्ये येतील? अल्फा अल्फा स्क्वेअर अल्फा क्यूब अल्फा. ओके, if you adjoin this alpha to the field f, there is no need to again join alpha square alpha cube. Okay, these are elements always also already belongs to f of alpha. Okay, any doubt?
No, sir.
Okay, so the next example is example number 4. If E is an extension of field f, capital E is an extension of a field f, okay, capital F belongs to okay, sorry, and f of x, small f of x, this is the element belongs to capital F of x, and the phi is an atomorphism. What is the meaning of atomorphism?
Isomorphism from set to set itself.
Domain and codomain का same असतो तुमचा isomorphism. Okay, so phi is
Yes,
an
sir.
atomorphism of E, leaving every element of F fixed, capital F fixed. Okay, then prove that phi must take a root of f of x in E into a root of f of x in capital E. Okay, what is the meaning of this sentence? So look at it. If E is the extension of the field F and f of x belongs to capital F of x, and phi is an automorphism of E, leaving the every element of capital F is fixed. You have to prove that phi must take the root of f of x in E into a root of f of x in E. Okay, suppose this one is the field E, sorry, F. Okay, and F is the E is the extension of the field F. Okay, what is going to us? Phi is then automorphism of E. Okay, so this one is the phi. This is our codomain F, and this one is the field again extension of F. Okay, now here the f of x belongs to what? Capital F of x. And phi is an automorphism. With automorphism means what? Domain आणि codomain कसा असतो तुमचा? एकच असतो, same असतो. Okay, now we have to prove that phi must take the root of f of x in E into a root of f of x in E. What is the meaning of this sentence? Suppose the A, suppose this A is the root of f of x. Then we have to show that this phi of A is also root of f of x. Okay, phi must take a root of f of x in E into a root of f of x in E. That means if A is the root of f of x, we have to show that phi of A must be root of f of x. Okay, root ha root la map होतो. Now look at the solution. Let this one is the f of x with the polynomial a naught plus a1x plus a2x square plus up to so on an x raised to n, where this a naught, a1, a2 up to so on an. Okay, all the coefficients are belongs to capital F. Why? Because f of x belongs to capital F of x. Now we know that E is an extension of F. Okay, what is given to us? E is an extension of F. Okay, and phi is an automorphism. Okay, phi is an automorphism of E. Okay, leaving every element of F is fixed. Leaving every element of capital F fixed. What is the meaning of this one? Phi of alpha is equal to what? Alpha for all alpha belongs to capital F. Understand? Whenever you take alpha belongs to F, या सेट मध्ये जेव्हा येईल हा अल्फा तुमचा तेव्हा काय होईल? हा आयडेंटिटी मॅप सारखा बिहेव करेल. Phi of alpha is equal to alpha. Okay, आणि हा अल्फा कशात कुठे येईल? तुमचा इथे. Okay, that is phi of alpha. Okay, yes. Thus phi of alpha is equal to alpha for every alpha belongs to F. Now let it all A here. Phi of A is equal to A for all A belongs to F. Okay. Now let alpha be a root of f of x in capital E. Okay, let alpha be a root of f of x in capital E. So this implies this alpha satisfies the polynomial f of x. What is f of x? A naught plus a1 alpha, okay, plus a2 alpha square up to so on an alpha raised to n is equal to 0. Okay, If alpha is the root of f of x, then we have a naught plus a1 alpha up to so on an alpha raised to n is equal to 0. To prove that, what we have to prove? Phi of alpha, okay, is a root of f of x in capital E. Okay, any doubt up to here?
No, sir.
Okay, now, what is the output? Phi of x. कुठे असेल माझा हा एलिमेंट? तुमच्या ई मध्ये, पीडी मध्ये असेल. वाय? बिकॉज एक्स हा एनी एलिमेंट घेतला डोमेन मधला, तर फाय ऑफ एक्स कुठे जाईल माझा? ई मध्ये. वाय? बिकॉज फाय इज द फंक्शन
Automorphism.
ऑटोमॉर्फिझम फ्रॉम ई टू ई. तुमचा डोमेन आणि
E
कोडोमेन
to
काय
E.
सेम आहे. ओके, नाउ लेट phi of alpha is equal to beta. The image of that root, काहीतरी माझं आउटपुट येईल. लेट phi of alpha, image of that root is equal to beta. Okay, now if suppose r, small r, is any positive integer. Okay, suppose small r is any positive integer, then phi of alpha raised to r is equal to phi of, okay, alpha raised to r means what? Product of alpha up to how many times? R times.
R type.
Okay, but phi is an automorphism. That means it is an isomorphism. So it preserves the multiplication. So we can write phi of alpha into phi of alpha up to r times. Okay, what is phi of alpha? Beta. Okay, so here beta into beta into beta up to r times. Okay, which is equal to beta raised to r. Okay, so this implies phi of alpha raised to r is equal to beta raised to r. Okay, any doubt up here?
No, sir.
Now, also phi of 0 is equal to 0. Why? Because phi is an automorphism. That means isomorphism. Isomorphism असेल तर काय होईल? 0 एलिमेंट
Identity
कोणाला मॅच
maps to
करेल?
identity.
0 एलिमेंट 0 एलिमेंट राहील. ओके, आयडेंटिटी मॅप्स टू आयडेंटिटी. वाय? रिझन काय?
Phi is automorphism.
ऑटोमॉर्फिझम आहे. ऑटोमॉर्फिझम म्हणजे काय? ते 1 1 आहे ना ते. 1 1 फंक्शन
Yes,
असेल तर
sir.
काय असतो? 0 मॅप 0लाच होतो
Isomorphism.
काय? 0 मॅप 0ला होतो. अजून ते रिझन काय ह्याचं? 5 0 1 1. ओके, 1 1 असल्यामुळे फाय फाय we can write phi of this 0 into alpha phi of, हा मला कसं प्रूव्ह करता येईल? मला phi of 0 हा 0 दाखवायचा आहे मला. कसं प्रूव्ह करता येईल? phi of alpha is काय? बीटा मायनस बीटा. ओके, असं येईल का? 0 मॅप होईल का? Phi of 0 is maps to 0 because since psi is an automorphism, phi is the function from E to E. 0 element of both E is same. Oh, okay. हा, तुमचं डोमेन आणि कोडोमेन सेम आहे ना, असं नाही ना. Okay. Phi leaves every element of f is fixed. हा f is fixed असेल तर काय होणार? हा 0 कशात आहे एलिमेंट? बिलॉंग्स टू f. ओके, हा रिझन. करेक्ट? इज इट करेक्ट? ते काय म्हणतोय?
Yes, sir.
Yes, sir.
Leaving every element of f is fixed होतो तिथे. Okay, so here phi of 0 is equal to 0. Give the reason here. Since phi leaves every element of capital F is fixed. Okay. Now we have to show that the phi of alpha, that is beta, is the root of f of x. Okay. Now we have a naught plus a1 alpha plus a2 alpha square up to so on an alpha raised to n is equal to 0. Okay, apply alpha on both the sides. A naught plus a1 alpha plus a2 alpha square plus up to so on an alpha raised to n is equal to phi of 0. कळलं आता हे का घेतलं दोन्ही?
Yes, sir.
Now phi is an automorphism. That means phi of here a naught plus phi of a1 into phi of alpha. Okay, directly like plus up to so on phi of an into phi of alpha raised to n is equal to phi of 0 is 0. Now here a naught, a1, an, all the ai's are belongs to field f, and phi leaves every element of f is fixed. So here this implies phi of a naught is a naught plus a1, phi of alpha is beta, a2 plus beta square up to so on an beta raised to n, okay, is equal to 0. Why? What is the reason? Phi of a is equal to a for all a belongs to f. Okay, phi leaves every element of f is fixed, and phi of alpha raised to r is equal to beta raised to r. Okay, so this implies, what it implies? This beta satisfies a polynomial. Which one? F of x. So this implies beta is the root of f of x. This implies phi of alpha is root of f of x. Okay, any doubt?
No, sir.
Okay, easy the example that I had. Okay, if E is an extension of the field f and alpha is the root of f of x belongs to capital F of x, and phi is an automorphism on E of E. Okay, then phi of alpha is also the root of that polynomial. Okay, याच एक्झाम्पलचा यूज करून पुढचं एक्झाम्पल आपल्याला सॉल्व्ह करायचं. Look at it. Example number 5. If the complex number, okay, Z, a plus ib is a root of p of x having real coefficient. म्हणजे काय तुमचा q of p of x हा कुठून आलेला आहे? r of x. Okay, real coefficient. Then prove that z bar. What is z bar?
A minus IB.
A minus ib, complex conjugate. Okay, write down the letter complex conjugate is also the root of p of x. कळतं आता एखादा नंबर कॉम्प्लेक्स, जर एखादा रूट कॉम्प्लेक्स असेल तर तो एकटा येत नाही, त्याच्या कॉन्जुगेटला पण घेऊन येतो. ओके, म्हणजे कॉम्प्लेक्स रूट्स असतील तर ऑलवेज ते इवन नंबर मध्ये असतात का? 2 4 6. ओके, एखादा पॉलिनॉमियल आहे आणि 3 कॉम्प्लेक्स रूट आहेत, आपण त्याला असं म्हणू शकतो. ओके, z is equal to a plus ib is the root of p of x, then z bar is equal to a minus ib is also root of p of x. ओके, म्हणजे तुमच्या इथे काय बेस फील्ड काय दिलंय, आर. हा तुमचा आर. आरचं एक्सटेन्शन कोण आहे, सेट ऑफ कॉम्प्लेक्स नंबर. दिस वन इज सेट ऑफ complex number. P of x belongs to what? R of x. Y is the automorphism on set of complex number to set of complex number. Okay, if suppose z is equal to what? A plus ib is the root of f p of x. Okay, then phi of z, phi of z कुठेतरी इथं असेल. Okay, is also root of r of x. मग मला phi of z कसा डिफाइन करावा लागेल, phi of z is equal to z bar. जर मी हा फंक्शन 1 1 ऑन टू आणि आयसोमॉर्फिझम दाखवला तर काय होईल, phi of z काय होईल, हा रूट ऑफ दिस पॉलिनॉमियल. ओके, म्हणजे काय, phi of a plus ib is equal to a minus ib. ओके, एनी डाऊट?
No, sir.
No, sir.
ओके, म्हणून हे कॉम्प्लेक्स जे रूट असतात ते पेअर्स मध्ये असतात. ओके, सिंगल रूट कधीही येत नाही कॉम्प्लेक्स. ओके, देयर इज अ रिझन हिट आहे. If the complex number z is equal to a plus ib is the root of p of x having the real coefficient, then prove that z bar a plus ib, okay, is also the root of p of x. दाखवते 1 1 on 2 फंक्शन. दाखवता येत का, सांगतो कशा मॅपिंग वगैरे, त्याचं पुढचं तुम्ही प्रूव्ह करा. ठीक आहे, आन्सर सॉल्यूशन. Let capital R be the field of real number. Field of real number. Okay, and C, okay, be a field of complex number. The field of complex number. Okay, then R is contained in C, which is equal to, what is C? A plus IB, such that A and B belongs to R. Okay, या C ला आपण कसं काय म्हणू शकतो, R of I. Okay, if adjoint this element I to the field of real number, then it will become set of complex number. Okay, any doubt up to here?
No, sir.
Okay, now let z is equal to x plus iy or a plus ib. Okay, let z is equal to x plus iy be a root of p of x belongs to capital R of x. Let let phi is the mapping from set of complex number to set of complex number. Defined by pi of x plus iy is equal to x minus iy. Okay, now we claim that phi is an automorphism. Okay, सेट ऑफ कॉम्प्लेक्स नंबर वर 2 ऑटोमॉर्फिझम आपल्याला फाइंड आउट करतात. ओके, एक पहिला मॅपिंग काय सांगतो हे नीट लक्षात ठेवा. पुढे जाऊन फील्ड फायनाइट फील्ड मध्ये गॅलॉइड फील्ड मध्ये हे तुम्हाला हे लागेल करायचं. ओके, phi of x plus iy is equal to x plus iy म्हणजे आयडेंटिटी मॅपिंग हा सुद्धा तुमचा ऑटोमॉर्फिझम होतोय आणि phi of x plus iy is equal to x minus iy हा पण तुमचं काय होतोय 1 1 onto आणि isomorphism that is automorphism होतोय. Okay, so from the set of on the set of complex number we can define two automorphism. Okay, but on the set of real number we define only one automorphism. Okay, and the set of all automorphism from आहे पुढे नंतर होईल. Okay, now here we have to show that this phi is an automorphism. Okay, total proof. Step number 1 to prove that phi is 1 1 first of C. So, okay. Now to prove that phi is 1 1. What is the procedure to prove the 1 1? Let phi of A plus IB is equal to phi of C plus ID. Okay. By the definition of phi A minus IB, C minus ID. By the equality of two complex number, what we get? A is equal to C and B is equal to P. हे दोन नंबर इक्वल आहेत म्हणजे याचा अर्थ काय होतोय एक तर A इक्वल टू C हवा and B is equal to D. This implies right equating here these are real and imaginary part. Okay, this implies A plus IB is equal to C plus ID. So this implies phi is 1 1. Okay, any doubts?
No, sir.
Now, second part. To prove that phi is on 2. Range is equal to codomain. Take the any element from the range or codomain. Okay. If there exists a P image in domain, then phi is on 2. Okay. Now let A plus IB. This element belongs to C. The any element. Okay. This implies A minus IB also belongs to C. Okay, why? Because C is the field. So this implies such that if A plus IB belongs to C and A minus IB also belongs to C, such that phi of A plus IB is equal to what? A minus IB. Okay, hence for any element from the domain, codomain, we have the element in the domain A plus IB such that phi of A plus IB is equal to A minus IB. So this implies phi is on 2. Okay. Any doubt?
No, sir.
A belongs to C. B belongs to C. I belongs to C. IB belongs to C. A, sorry, minus IB also belongs to additive inverse, belongs to C. A minus IB also belongs to C. Okay, आता कळते? A plus IB also belongs to C. Okay, so for every element from the codomain, we have the imagine we have the element in the domain so that A plus IB is equal to A minus IB. Okay. Now, third step to prove that the phi preserves the addition and multiplication. To prove that phi preserves addition and multiplication. Okay. What is phi of A plus IB? Okay, product of two element into C plus ID. Very clear हुए? Phi of A plus C plus sorry into plus I into B plus C. Okay, from the definition we have A plus C. Okay, plus का क्या होता है minus complex conjugate plus minus I into B plus D. This implies. Any doubt?
सर प्रोडक्ट घेतलाय ना.
हो प्रोडक्ट घेतलंय का बघा ना प्रोडक्ट A into C नाही ऍडिशन आहे सॉरी A
ऍडिशन आहे सर.
into ओके आता येईल करेक्ट
यस सर.
okay so this
Yes, sir.
implies phi of A plus IB plus phi of C plus ID आधी addition proof करायचं okay so this implies phi reserve addition now and phi of A plus IB into C plus ID which is equal to phi of AC minus BD plus I into AD plus BC. Okay, after the multiplication, we get this one. So this implies, by the definition of phi, this one is AC minus BD minus I into AD plus BC. So this implies A minus IB into C minus IB, which is equal to phi of A plus IB into phi of C plus ID. Okay, so this implies phi deserves the multiplication. Okay, thus phi is an automorphism of C. Okay, now step number 4. You have to prove that phi leaves every element of base field. Okay, what is the base field here? R. Okay, तो काय करतोय फिक्स्ड करतोय फिक्स्ड एलिमेंट होतोय okay now if A belongs to capital R okay आता हा कॉम्प्लेक्स नंबर नाही आहे तुमचा हा रिअल नंबर आहे कॉम्प्लेक्स तर आहे पण इमॅजिनरी पार्ट नाही आहे तुमच्या इथे सो A is equal to A plus what I 0 this is the element from the set of complex number so this implies phi of A is equal to phi of A plus I0 is equal to by the definition of I phi A minus I0 which is equal to A. Okay, hence this implies phi of A is equal to A for all A belongs to R. तुमचे जे बेस फिल्ड काय सेट ऑफ रिअल नंबर ओके तर तुमचा इमेजनरी पार्ट नसेल तुमचा okay so phi of A is equal to A for all A belongs to R that is phi preserves or sorry phi leaves every element of capital R okay is fixed okay thus by previous theorem okay by previous theorem if z is root of p of x then phi of z is equal to here z bar is what also root of p of x in set of complex number okay hence this is the proof any doubt up to here
No, sir.
No, sir.
ओके, काय अडचण असेल तुम्ही विचारू शकता. Okay, solve one example at home. Okay, example number 6, homework. If small m is an integer, okay, small m is an integer which is not a perfect square. What is the meaning of perfect square? 1, 2, 1, 4, 9, 16, 25 are the perfect square numbers. Okay, here the m is an integer but not a perfect square. And alpha plus beta root m. Okay, perfect square नाही आहे म्हणूनच इथे घेतलंय स्क्वेअर रूट, म्हणजे त्याचा स्क्वेअर रूट निघणार नाही. Okay, where alpha and beta are rational. Okay, rational number. Alpha and beta are rational number. Okay, if alpha plus beta root m is the root of polynomial p of x, p of x having rational coefficient. Okay, then prove that काय प्रूव्ह करायचं आहे, अल्फा मायनस बीटा रूट m is also a root of p of x. ओके, हेल करता असंच फंक्शन डिफाइन करायचं, फाय ऑफ अल्फा प्लस बीटा रूट m is equal to अल्फा मायनस बीटा रूट m. Okay, if you show that phi is automorphism, then by previous theorem, if z is the root of p of x, then phi of z is also root of f of x. Okay. Okay, आता तुमच्या इथे बेस फील्ड काय येईल, सेट ऑफ रॅशनल नंबर. ओके, आणि एक्सटेन्शन फील्ड काय येईल, सेट ऑफ रियल नंबर. ओके, फाय कसा डिफाइन करणार, फाय अल्फा प्लस बीटा रूट m is equal to अल्फा
Alpha
माइनस बीटा
minus
रूट m.
beta root m.
ओके, हेल करता.
Yes, sir.
Okay, to solve this, okay, wait a minute. Okay, any doubt up to here? काही डाऊट असतील तर विचारू शकतो. Okay, so thank you for the attending the lecture. Okay, for today it is sufficient. The remaining part we will see the next lecture tomorrow. Okay, the characteristic of a ring. What is the characteristic of a ring? Okay, and characteristic of field also. Okay, so for today it is sufficient. Thank you for the attending the lecture. You can leave now. Thank you.